is crucial. In particular, GTRBAC can have two anomalous situations. First, we could have simultaneous occurrence of conflicting events. For example, at the same time, enable role, particular role, R, can occur with another event which is trying to disable the same role. Similarly, we could have arbitrary triggering of triggers based on events that are validated at particular time, generating ambiguous semantics. We'll look at a simple example. And to take care of these cases, we have conflict resolution rules. Basically, we use higher priority text precedence, disabling event or negative text precedence when there are same priority opposing events. For example, disable R takes precedence over enable R if they have the same priority. And also, since we have activation time constraint, enabling time constraint, we use more specific constraint to override the less specific constraint. So to capture these two anomalous situations, we have a event dependency analysis that actually tries to find out set of triggers that may give very ambiguous semantics. And having removed that ensures good behavior on the execution of the model. And at runtime, we could still have a need to resolve conflict when events of opposing nature occur at the same time. And we use primarily priority-based conflict resolution. And we have categorized three types of conflicts in GTRBAC. Type 1 is essentially between events of same type but of opposing nature. So enable R and disable R are events trying to address the same issue, but they have different opposing effect. So if they both occur at the same time, we basically use priority to resolve. Type 2, there could be cases where dissimilar types of events, but somehow they oppose each other. For example, if there is an activation request to activate role R for you, and at the same time there is another event deassign R for you, we want to be able to resolve this case because you can't grant both the event request. And type 3, we could have constraint specifications that are themselves conflicting. For example, we could have two duration constraints where duration specification might be different for the same event, or you have different durations, but the opposing events are specified. And similarly, we could have per role specification, which is more specific, per user role specification, which is more specific than per role specification. So here we simply use more specific overrides the less specific case. So as I already mentioned, type 1 conflicts we simply resolve by using priority, takes precedence rule, and if we have this same priority on the opposing events, we do the disabling event takes precedence. For type 2, activation event has lower precedence. Basically, type 2 event, conflicts occur when you have an activation-related event and another non-activation related event trying to occur at the same time, but they have opposing effect. So we give less priority to activation event because, for example, if a role is disabled, we should not be able to activate it. Type 3B, it's, as I have already mentioned, most specific specification overrides the less specific. So per user role is really more specific because it says given a user and that particular role, the constraint is this. But per role is only for given that role, the constraint is as pre-specified. So here's an example. If you have this set of events trying to occur at the same time, then based on this resolution, some of the events need to be discarded. And I mentioned about triggers creating ambiguous semantics. If you look at this example, we have two triggers. First one, enable R1, enables or disables R2. If you have enable R2 event occurring, then disable R1 event should also occur. And if you assume that at runtime you have these two requests generated, enable R1 and enable R2, depending on which one you take first, you have two different set of events selected for firing. For example, if you take enable R1 first, it fires TR1. That means disable R2 will also be an event that needs to be fired, which means TR2 cannot fire because disable R2 is already there, and TR2 starts with enable R2. Similarly, if you take enable R2 first from the runtime request set, then you fire TR2, trigger TR2 first, and include disable R1, which is on the right side of the trigger. But once you do that, you cannot fire TR1. So based on which one fires first, which you chose, you have two different set of events, valid events you can compose. So we want to avoid that because that's ambiguous given a particular request and particular trigger set. It has multiple paths, and we want to be unambiguous in such situation. And to avoid such situation, we employ level dependency graph technique to detect the ambiguity. And if you look at, we have an algorithm. If you look at the previous example with TR1 and TR2, it essentially generates, based on this algorithm, this directed graph with labels plus and minus. And by using analysis of this directed graph to find some cycles which have particular labels, we could identify those trigger set which can possibly generate ambiguous semantics. So the result basically is, if you have a set of triggers, we can say it is safe if the level dependency graph has no cycle with particular label. And it can be computed, the cycles can be detected in polynomial time. Now let's quickly overview role hierarchy. We needed to revisit role hierarchy because now we have roles with time constraint, and once roles have temporal duration, how two roles which are related through hierarchical relation changes the inheritance semantics. So if you remember, role hierarchy is there basically to allow a senior role to inherit permissions that junior roles have. But since senior and junior roles can themselves have different time intervals associated with them in which they can be enabled or disabled, the semantics can change significantly. So we looked at this issue. Basically, temporal role hierarchies, we tried to capture all the fine-grained semantics that can be introduced by having time constraint by separating the permission inheritance and role activation inheritance semantics. We'll quickly look at that. And also, this separation allows capturing